Mother Nature has taken over all of man's creations. Submarines, the enormous metallic tubes that delve far below the surface of the ocean, are no exception. The Titanic-bound submarine Titans collapse at a depth of 3.8 kilometers as a result of intense oceanic pressure is shocking news. We intend to go deeper to heighten the fear. Ever ponder what occurs to a person's body when a submarine explodes? It's a subject that makes you shudder and makes you realize the powerful forces at play. The response is a horrible one, where the body is crushed by the water, and everything happens so quickly that no one even feels the pain. How then does this water function? How does it accomplish this so quickly? You see, a submarine implodes at a startlingly rapid pace. Imagine the hull rushing inward at the astounding speed of almost 2,200 feet per second, or 1,500 miles per hour. The hull radius of a contemporary nuclear submarine is roughly 20 feet for comparison. Thus the mind-boggling 1 millisecond required for total collapse. Yes, you heard correctly, everything occurs in the space of a single blink. Anything smaller would be crushed even more quickly. Implosion speed versus human response. The human brain is an amazing organ that can assimilate stimuli and react instinctively. But our logical response just cannot keep up with the submarine's lightning-fast implosion. While our brain reacts to stimuli in an automatic manner in just 25 milliseconds, the full sense to reason to action cycle takes, at most, 150 milliseconds. In a little fraction of that time, the enormous implosion occurs, leaving little time for any cognitive response. The current occurrence has put oceanography and the issue of what happens to the human body during an implosion under intense scrutiny. An implosion is described as the act of collapsing into the center in the Oxford Dictionary. In contrast to an implosion, which forces objects inward, an explosion spreads materials outward. A crushed can that is pushed inwards is an illustration of it. Compression is the result of an external force exerted on the system. For instance, when you push a can inside by crushing it with your fist. In this video, oceanic pressure crushes the monster can from the inside out. We are now aware of what an implosion is. But what is this strange ocean pressure that prevents humanity from venturing into the ocean's depths? The force generated by the weight of the water in the ocean is referred to as ocean pressure. The weight of the water above you grows as you descend deeper into the ocean, increasing the pressure. In the ocean's depths, this pressure can be quite high. Ocean pressure, put simply, is the squeezing force that water applies to underwater objects. As a result of the weight of the water above them, oceanic pressure pulls everything towards its center from all directions, the deeper any object goes. Humans are capable of diving as deep as 500 meters, with the right equipment and breathing gases. Yet this has never been done for safety reasons, and is only done for research purposes. Only 60 meters can be reached by humans without sophisticated equipment. This is negligible, given that the ocean's average depth is 3,688 meters. This reveals the perilousness of deep oceans. The formula pressure equals depth times gravity times the water's density can be used to determine oceanic pressure. The decibel is a measurement unit frequently used to describe marine pressure. A decibel, or 1/10 of a bar, of pressure is about equivalent to the atmospheric pressure at sea level. It is frequently employed in oceanography and marine sciences to express water pressure at various ocean depths. At the Mariana Trench's deepest point, which is 11,000 meters down, the pressure is 1,086 bars, or 15,750 psi. The pressure one would experience at that ocean depth can be compared to the feeling of having 100 elephants standing on your head. In order to understand its magnitude, we now comprehend the force responsible for the submarine's implosion. We can now examine the incident closely. The internal explosion, the trapped air inside the submarine, behaves like an engine piston. When its hull collapses, an explosive explosion is the outcome of auto-ignition caused by the abrupt compression of air. As the point of collapse spreads, the water in the area rushes in quickly. The air inside the submarine is compressed by the water under hundreds of tons of pressure per square meter, raising the temperature. Hydraulic oil, auxiliary engine diesel oil, cooking oil, grease, rubber, and plastics all cause hydrocarbon vapors to be released into the environment of a submarine, which promptly detonate. What occurs to people inside the submarine? The response is simultaneously scary and reassuring. The oceanic pressure would be roughly 6,000 pounds per inch, at a depth of 3.8 kilometers. Calculating the pressure the passengers experienced and comparing it to the average human body revealed that it was approximately 18 million pounds of pressure per inch. When numbers are this large, they frequently become meaningless. That would feel similar to a hydraulic press crushing a toothpaste tube. The repercussions for the human body within the submersible if it suddenly imploded would be terrible. The body of the person would be immediately and severely crushed by the sudden compression of the environment. Due to the significant and quick shift in pressure, this process would happen in a split second. The body's gas-containing organs, including the lungs and digestive system, would be affected by the compression and may implode or collapse as a result. Water would also be forced into body cavities like the nose, mouth, and ears by the water pressure. Significant internal injuries, such as hemorrhage and organ damage, could result from these abrupt shifts in pressure. One benefit, if there is one, given how quickly the implosion happened, it is unlikely that anyone would feel a lot of pain. The majority of human tissues are fluid-filled and largely incompressible. Human lungs and sinuses would be quickly crushed, and the intense shock would knock individuals out almost immediately from the extreme stress and oxygen deprivation, and they wouldn't even be aware of it. Instantaneous and painless deaths occur. Regarding the visuals, the implosion would send a strong shockwave across the water, creating a sudden cloud of debris that would include the wrecked submersible and, regrettably, the shattered remains of the occupant. The water would then quickly pour back into the abyss, adding to the chaos of the scene. What happened to the passenger bodies is the last query we reach at this point. Where did all the dead people go? Or at least that which is left? The bodies would first experience extreme heat. When the air bubble the submarine has built fails, the pressure from the outside will compress the air inside, causing it to heat up to a scorching 10,000 degrees Fahrenheit, or the temperature of the sun. If there was anything left of the bodies, it would be transformed into gel and discharged at a very high speed. The compacted process meant that it would soon be ejected outward and become food for the organisms below the surface of the water. Thank you for viewing. Get more stuff by subscribing to our channel. Until the next video, take care.